Seems like there's some lag between the screens. Hello, everyone. Welcome to the workshop. I guess we are waiting for a few more people to join. We'll get started in a couple of moments. Awesome. All right. So we are all here for the workshop on Python Power Boost, how to code smarter and run faster. Let me start with a brief introduction. I am Bharat Tiwari. I am a software development engineer with Amazon. I have over 12 years of experience in the IT industry, dual master's degree in electrical engineering and computer science from Arizona State University. And in general, I'm just a tech enthusiast. I like to stay up to date with the latest trend in technology, let it be big data, microservices, machine learning, Gen AI, you name it. I try to keep myself updated and love to talk to others about that. So if you're someone who wants to discuss about that, do feel free to keep in touch and yeah, ping me after this presentation. So coming back to the topic for today, Python Power Boost. Can you hear me now? Just give me 1 second. All right. Can you still hear me? Fine.
Yeah.
All right. So yeah, as I was speaking, uh, today's objectives are to learn practical techniques to optimize Python code. And from this workshop, what you will gain is some insight into identifying and fixing inefficiencies. I'll be sharing some hands-on examples to apply optimization strategies. And in addition, you will gain some skills to make your Python code faster and more efficient. I don't have too many slides here. I want this session to be more interactive. So if something is not clear or if you have some more questions, do feel free to post a message in the chat and I will try to address those. All right, so why Python today? What's the reason uh, we want to know more about Python today? Um, is it possible to get a vote on this? So how many people are using Python today in their day-to-day life or at their work? I see a few responses. All right, looks like some of us do, and we do love using Python. That's awesome. So one of the main reasons that I feel now is the best time to learn Python is with the advent of generative AI. Due to simplicity of Python, the readability, the extensive ecosystem of libraries and frameworks, there is a lot of good opportunities that Python serves. It can be used for various use cases in generative AI, especially with uh, the different web service frameworks like Fast API that are available now. It's very easy to use Python to develop an application and just showcase your skills. Most importantly, there are some libraries which are readily available with Python, like Pandas, some which are built on top of that, like Polars, which are very good for data processing when you if you are going to do anything with data. Those are the two libraries. For machine learning, you have scikit-learn, which also offers a lot of good functionality for training your models, using your models, evaluating the models, and such. And then for neural networks and moving towards AI, you have PyTorch, TensorFlow, and Keras. I myself did a lot of project work on PyTorch when I was doing my master's, and I can tell you it's an awesome library to learn about. And on top of that, it's open source, so you can just go into it, look at the code, and if you want, you can contribute to the code. And there's a lot to do with that. So next thing, why high performance Python? So Python is versatile, but it can be slow in certain scenarios. There are various reasons why someone might think Java is better than Python, especially for developing web applications. Java has been used more widely because of its object-oriented design support and the fact that it offers compilation in advance, just-in-time compilation, and a lot of features like that. Well, Python also offers a few compilers like PyPy and a number and some more, but it as in general it lacks the ability to do that out of the box. You might have to add some more annotations or let the compiler know what you expect a particular variable to be, since the variables are dynamically typed in Python. So it adds a bit of overhead when developing Python and doing the pre-compilation. But you'll be happy to know there is a project going on to improve the compilation in Python as well. And soon, maybe a couple of years down the line, we'll be able to compile the any Python code straight out of the box rather than looking for alternatives or working around things to do that. There are there are some bottlenecks in Python, and understanding those will be crucial for building scalable applications, handling large data set efficiently if you are trying to become a machine learning engineer or an AI engineer. You should be familiar on how to handle large data sets, and understanding the bottleneck helps there. It can also help reducing runtimes in critical systems, especially when in case of slow loading websites or apps. The different frameworks available in Python for developing web apps like Django, Flask, had a bit slow. And with the recent framework with Fast API, we are already overcoming some of these bottlenecks. So let's understand how we can achieve that high performance. And the first step is profiling. So why do you need to profile? There are certain functions which you can use during your development, like the time library available out of the box from Python. You can use time to time a particular small piece of code. But when you have a full-fledged application, or maybe a legacy application, you want to do some kind of profiling to understand why exactly the application is running slow, which part of the code needs to be looked into, and what we can do to make it faster. So there are some popular tools for beginners like cProfile, which is available out of the box from Python. It measures the function execution times. There are some code examples below. We'll look into that. There are some advanced profiling options like Line Profiler, which you can do a pip install, and then it gives you line-by-line performance of your code. So for example, we have here use of cProfile and Line Profiler demonstrated. So let's look at the function to calculate the sum. It's a very simple 3-line code. Function name is calculate sum. It returns the sum of a range of numbers to 1 million. So we can simply import the cProfile library and pass the function call to the cProfile run function, and it gives us an output like you see on the right. And it clearly shows what all functions are being called. So there we see there are some built-in method, built-in.exec, built-in method, built-in.sum. These are the Python built-in ones. And then you get a clear picture of how many calls are made, the total time, the per call latency, the cumulative time. So this is a great tool to start with. As I said, it's tools for beginner. So this is something that you can do very quickly to look at your code and identify which part of code is taking too much time, if the cumulative time is more than expected, and then you can act on that. There is an example of the line profiler as well at the bottom. I pasted the GitHub link here so you can look more into the code and how it does that. It comes with a good README, so I will encourage you to go and look into that yourself. The next step of achieving high performance starts by looking at small things. We need to understand where our data is being stored and how the data is being stored. For instance, we know the data can be stored in memory, in hard disk, or in some cold storage on a network drive somewhere. So the location of storage matters, but at the same time, the data structure we use also matter. So I have put together here some common data structures, which are very basic ones, which and we need to understand how and when to use those. But there are some advanced data structure which are more geared towards a particular use case. So let's start with the common choices. So Python offers lists. These are dynamic arrays which are great for ordered data, but they are slow for lookups. To find a particular number in a list, it's an operation of O(n) if it is not sorted in a particular way. So if we have to check for membership, we go for sets. Sets are really fast for membership testing, and they are a good alternative to lists when it comes to membership testing. We also have dictionaries, which is ideal for key value lookups. In fact, many of the caching systems, caching libraries still use dictionaries, as it offers O(1) lookups for keys. We also have MinHeap, which is ideal for getting top K values. For example, if you want to see what are the top three uh, or the the largest three numbers in an array, MinHeap is something to go to. Let's look at an example of how it matters for list versus set. As you see in the example, we have a simple name list, and which is of 1,000 elements. If you convert it to set, the operation can be done in O(1) rather than O(n). So this is a very simple optimization, but it does matter in the big picture when such operations are multiplied and you have multiple data structures in your application. Then there are a few code optimization techniques. For example, you should always avoid redundant caching, redundant calculation, so use caching for that. How to do that? You have some built-in libraries which help you do caching, or you can simply use a dictionary to memorize your code and reduce the runtime. Next option is minimizing loops. Python has some great libraries like NumPy and Pandas, which help you vectorize the operations. So if it is multiplying an array of numbers with another array of numbers, it's very fast and very optimized if you use NumPy rather than running for loops and doing that. Next point is leverage built-in functions for speed. We will look into a few built-in functions on the next slide. The next option is to leverage generators. Generators help us by loading the variables in memory only when when an actual calculation is required, rather than loading everything in memory within every functions. We will look at how generators are useful a little bit down the line. So I was talking about built-in functions. Here is an example of how we can use a built-in function. We look at finding a factorial using a loop, and look at the runtime using timeit. So as you can see, we have a function called factorial loop. We just loop from 1 to 100, and we multiply in each iteration of the loop and return the result. The time taken for this particular function running as with a loop is about 0.1 second, 0.01 second. Whereas if we do it with a built-in function, math.factorial, the improvement in latency, or the runtime is 10x. Just to explain the statement here, timeit takes in the function or the statement that you want to calculate the runtime for, takes a few lines to set up the calculation of time, and finally how many times it runs it to calculate the exact runtime. So you can see with simply using a built-in function, we can get 10x improvement in speed. Next, we come to caching. So this is a simple example of how we can use memoization for caching. We can, for example, when we are checking for a prime, rather than doing it for every number, um, rather than doing it for a number throughout, we can just cache the result in a dictionary called memo, and we can straight away return the result if the result is already available, rather than going through the entire list and calculating it for every number. So this is a simple technique. We will also look at some other options to do that. Next, let's look at vectorization. As I was talking about NumPy, so for calculating squares, a trivial way of doing it is initialize an array, and for all the numbers in the list, we just multiply it and append to the result array. Whereas a vectorized approach for this will be to use NumPy for that. So we initialize a NumPy array, and we just use the power operator to do array multiplication, and this way we can improve the runtime because NumPy is optimized for vector operations. Next, let's look at some uses of generators. So we can use generators to create generator functions. For example, when we are trying to, there are some trivial examples how we can do generation of numbers, but as we see, we can have a function which just yields certain values, and the value is only used when the function is only loaded into memory when we actually use the function call and the number that is coming out of it. Other option for generators is shown here, like in list comprehension, we can also use generators by just replacing the square brackets with the parentheses, and this is a simple way of how we can divide each number by 2 in a particular range, and this value is only loaded into memory once we iterate over those. This is really useful, for example, when you are loading something from a database, doing certain operations and saving it back. You might have a complex logic where you have to pass the list around for a few times, and by just changing the list comprehensions with generations, it improves the runtime a lot. We can also leverage some built-in modules. So like I was talking earlier, there is a built-in module called functools, which offers tools like caching. So you can just use an annotation like @cache on a factorial function, and it catches all the already calculated values. So if this is done the second time, it will be much faster. There are also other modules like itertools, which offer a number of functions for memory efficient looping, like accumulators and whatnot. I have pasted a link for that here. So I will encourage you to look into that. And there are some awesome tools which you can use to improve the memory efficiency of looping. We also have some built-in modules in collections. You can, for example, the default dict. In general, when we have a dict, a dictionary, we have to do a get call and provide a default value for every call to make sure that we always get a value. We don't need, even if the key doesn't exist, we can get the value, or we have to do an implicit check that the dictionary contains the key. But default dict offers a clear and succinct way of doing this. And you can, when you initialize the variable itself, you can say what's the default value that you are expecting. Here is an example of how you can use iter-tools combinations. So we import the iter-tools, and then we can use that to create combinations of I think the slide is still loading again. Okay. So, and to generate combinations of different elements in the list, we can use the iter-tools.combinations to generate all combinations with two elements. And as you see, it's very simple to use and it's highly optimized. Next option that we have is using parallel programming. Sometimes, it helps speed up the CPU-bound tasks like computations, and it helps us handle multiple tasks simultaneously. These tasks can be I/O bound or network bound. So we might be reading from a large file or writing to a large file or waiting for a request to complete from and or yeah, we can be waiting for some network operation, things like that. That's where parallel programming helps. So there are some basics of parallel and concurrent programming. We use threading. We use threads for I/O bound tasks. We use multiprocessing for CPU heavy tasks. For example, we can use this to sort a large file in parallel. Here is a code example to show how a parallel file sorting works for microprocessing. So we import the pool built-in function, built-in module, and we define a simple function to sort chunks, which returns, given a chunk, returns sorted version of the chunk. And yeah, we can create new pools, and to each pool, we can do a pool.map, provide the function to sort the chunk, and pass in the chunks, which are nothing but the input divided into chunks of 3 elements. Finally, we can sort the sum of these chunks and create a list out of that. This is a trivial example of how to do it, but it has a lot of power and it can be used in multiple use cases. So we have a question about async function. Is parallel programming the same as using an async function? So async function is basically to continue the working of your program while and not stop the actual processing of the program for response to come back. So it invokes a new thread, and that thread waits for the response to come, and your main thread can continue while the secondary thread waits for the response to arrive. All right. So with that, it was a short presentation. I did touch upon a few things, but there are some key takeaways there. Always profile your code before optimizing. Use appropriate data structures and built-in modules wherever possible. Optimize for readability and performance balance. And finally, test and verify every optimization. Some of the resources for further exploration is maybe you will like to look into Python compilation. There are some tools available like JIT, PyPy, CPython, Numba. These are the current compilers available for Python, and I will encourage you to look into that. And there are a lot more new stuff coming into for that. When talking about multiprocessing and multithreading, inter-process communication is a great tool to achieve higher performance. So I will encourage you to look into how these can be done. Finally, I would like to encourage you to look into how you can create your own code extension for Python with Rust or C language. Most of the inbuilt Python libraries are currently written in C, and Rust is another alternative to do it. And Rust has another other advantages, and it's for some in some profiling research, it has been shown to even uh, give better performance than C. So I will encourage you to look into Rust and see how you can create simple modules and use that as an extension for Python. With that, I will close this presentation. Um, I will encourage everyone to join different hackathons and contribute to open source projects. This is a great time to look into open source. Some of the things that you can look into is PyTorch. There are other new projects coming up like TyPy, which is something related to GenAI and how you can generate a quick data dashboarding or application for data using GenAI and the power of Python. With that, I'm done for the presentation. Any questions? Okay, I see a few questions in the messages. Let me go one by one on those. Okay. All right. So how do you choose the right data structure for a specific problem in Python? I touched upon some of the basic data structures that are available in basic Python. I will encourage, if you are in college, to take a data structure course, which touches upon the different data structures, the use cases, what's meant by a big O notation, and that way you can choose the right data structure for your work or whatever you are trying to accomplish. Or if you have any further question, feel free to reach out to me. I'll share my contact with the staff team and they can share it with you. If I'm new to coding, would you recommend learning Python as my first language? Definitely. Python in my opinion, Python is a very easy language to get started with. And it's something that has a low learning curve, and it's very easy to get started on that. There is a lot of community support available. Um, there, there are websites where you can go and which offer you free newsletters to learn more and more about Python. Like you can check out realpython.com. That's a great resource to learn Python. And I also, it's my personal opinion, but whenever it comes to any coding interview, I like to use Python because what I can do with Python in 15 minutes takes a lot more time in other languages. So I will definitely recommend learning Python as first language. What's the best advice you can give to a high schooler who wants to succeed? Mm, this is a tough one, but one of the advice I can give to you is never be afraid to learn and always try to apply whatever you learn. If you are stuck anywhere, uh, look for different resources available online or look for certain mentors who can help you guide you in the right direction and who can unblock you. There are a lot of people who are looking for people to mentor and share their experiences and successes with. So keep learning, keep applying your skills, and definitely you will achieve success in your life. I'm learning Java in school right now. How similar is that to Python? So I briefly touched on what is the difference between Java and Python. Java has a rich libraries for object-oriented programming, and at the moment, it is possible to achieve better performance with Java code. It's also widely used in the industry for developing web applications, especially. So, if you for enterprise use, Java is a preference. Python is more of something that is used for uh, data processing or big data, or it's used more in machine learning. It has rich libraries for vector processing like NumPy, Pandas, Polars. So Python takes you in that direction, machine learning, Gen AI, artificial intelligence. Um, if learning one or the other is a difficult question again, because they offer different benefits. But yeah, like I said, if you are starting new, definitely look into Python as well. I am confident in my Python skills. However, I have not gotten any real world experience. I have contributed open source and won hackathons. But how do I get an internship as a high schooler? So one advice or couple of advice I can give to you is it's great that you are doing hackathons and contributing to open source. But one other thing where some of the techies lack is highlighting these achievements. So I would encourage you to showcase your skills by professional platforms like LinkedIn, uh, where and try to be active on that. Try to grow your connections. Try to network as much as you can. Try to share your knowledge or whatever you have learned. Just write about that. This gives you visibility and people are watching there, so that will definitely help you land your internship. And the second thing I will say is keep contributing to open source and make sure your GitHub profile is good, because recruiters often look at these GitHub contributions and see how active you are at coding. And that's one of the factors that they take in when they are looking for people to hire. So I will I will encourage you to do these two things at least. Okay. How can I find a mentor? Um, so best way to find a mentor is reaching out to people um, in a professional network like LinkedIn. So if you see, you can look for people who are working in a similar field to which you aspire to go in. So for instance, if I'm looking to grow a career in AI, I will look for someone who has been a great contributor in AI. You can nowadays there are a lot of tech forums where you see articles from some of the techie guys. So for example, you can check out medium.com or Substack, or there is dev.to. It's a relatively newer platform where people are posting articles. So go to those platforms, look at who is posting, what they are posting, explore your interests. It will not only increase your knowledge, but you will also get to know some of the leading people who are leading in different fields. And then you can reach out to them using uh, LinkedIn, or even those forums sometimes offer opportunity to reach out to the author. And yeah, just feel free to reach out to them and ask them for help. I'm sure uh, uh, whoever is there will definitely reply to you and will agree to mentor you. All right, I see no further questions. Um, With that, I would like to wish you all the best for the future and the hackathon. Thanks, everyone.